So hello everyone. In last class we talked about resistance. We talked that when an electron flows through a conductor or a wire, what you see that they come across hurdles, and so what that hurdles are called, that is nothing but resistance. So now today we are going to talk a bit more basic, that actually what leads to the flow of electron, why actually the electron flows through a wire. So to understand this basic concept, what we are going to do, we are going to deal with three main topics, and those three topics are nothing but, first we will be dealing with potential, second we will come to potential difference, and then we will deal with electric potential energy. So let us start with potential first. So to understand this topic, what is potential, let us take few examples. We know that suppose we have two buckets, two containers containing water. Suppose we have a container A and container B, both have water inside it. We know that container B has more water as compared to container A, but the only thing is that container A is kept at a greater distance or a height than container B, because container B we have kept it on ground, whereas container A is at certain height, suppose let's say H. Now in this case, if I want to connect these two containers via a pipe, what we will observe is that water from container A will try to flow towards container B. Though we know that container B has more water, it does not have anything to do with the direction of flow of water. So what is the most important thing to do with? The most important thing here, the deciding factor here, is the height. So in case of water flow, the deciding factor of its flow is only decided by the height of the container, or height at which the water is placed. So one with a greater height, if suppose we have two containers, one with a greater height, so water will always flow from a higher altitude towards a region of lower altitude. Similarly, in case of air, if we talk about air, what we see that air always flow from a region of higher pressure to a region of lower pressure. So these are the conditions basically. So when we talk about potential is nothing but it is a condition which decides the movement or the flow of any object. So from where or which direction an object will flow is decided by potential of it. So let us take a very simple example. Suppose we have a flat table. We have taken a flat table and we have kept a ball on it. So when we know that it is a perfectly horizontal table, this ball is not going to roll in any of the direction, neither this side nor this side. But suppose what we have done, we have just tilted this table a bit. Now we have just tilted the table a bit. Now what we are going to see, that ball will roll in this direction. So what happened? We created a condition for the ball to move, and this is nothing but potential. So what is potential? Potential, in a very vague term, in a very layman's word, if you want to say, it is nothing but the condition which decides the movement of an object, in which direction the object will move. That is it. So it's nothing but the condition. Now to be more specific, let us talk about a more specific term that is called as potential at a point. Let us understand a more specific point that is called as potential at a point. So what is the potential at a point? So for that, before going into electricity directly, we will first try to understand it in terms of gravitational potential. So what we have here, suppose we have a ground, this is our ground, and we know that we have a gravitational force directed towards the center of the ground. So let us say that these lines are nothing but depicting the gravitational force or the gravitational lines of force. Now here, suppose we have a ball of mass 1 kg. Now we are trying to take this ball to a height h. Suppose height h. So we know if we have taken this ball from the ground to the height h, we know that potential energy of this ball will be mass of the ball g times h. This is the potential energy of the ball. Now if I want to find the potential energy per unit mass, so per unit mass means we have to divide that potential energy with the same mass of the ball. So what are we going to do? Potential energy per unit mass is nothing but mgh by mass of the ball. Here we know it is 1 kg, so here 1 kg get cancelled, we have gh. So what we see, that potential energy per unit mass is independent of mass itself. It is only equal to g into h, g times h. What is g? G is nothing but acceleration due to gravity, and h is the height above the earth's surface. So suppose in this case we have taken a ball from ground to a height h. So what is the potential energy per unit mass? Pe per unit mass is nothing but g times h. Suppose we have taken the same ball from ground to a height, suppose h1. So in this case, Pe2, let us say Pe1, Pe2 per unit mass is nothing but g into h1. And we know as h1, we can say as H1 is less than H, hence PE2 is less than PE1. So PE2 is less than PE1. So now we can define potential at a point as in this way. Potential at a point is nothing but the work done per unit mass. So if I'm talking about potential at point A, what is potential at point A? It is the work done to take this ball from ground, to lift the ball from ground to a point A per unit mass of that ball. So that is the potential at A. Similarly, the potential at B is we can say the work done to lift a ball from ground to a height h1 at point B is nothing but potential at point B. Similarly, in same things, and what we should observe from here, we can have an important observation is that as we are moving against the direction of this field, gravitational field, we have to do more work. Here we came at a greater height, we moved a bit more against the gravitational field, so we have to do more work. If we are trying to go here, we will have to do further more work. So as we are going to move against the gravitational field to a higher height, like greater height, we will see that potential at that point will be greater. Suppose this is a point C, so potential at point C will be greater than potential at point A, and it will be greater than potential at point B. So as the height above the ground surface increases, the potential of that point will increase. Similar is the case in terms of electric field. Suppose we have a charge. Suppose we have a charge placed at infinity. Suppose we have a charge placed at infinity here, Q, and what we are going to do, we are going to bring this charge from infinity to some point, say A, in this electric field. So we are going to bring this charge Q from infinity to a point A. So obviously we have to do some work. Let us say work done is W1. Now we are going to bring the same charge in second attempt. What we are going to do, we are going to bring the same charge Q from infinity to a point B in the same electric field. We know that since we have to cover a lesser distance here, so in this case we have to do less work, W1, and in this case suppose the work done is W2. We know that W2 has to be greater than W1. So if I want to define the potential at this point, potential at point A, potential at point A, we can say work done to bring the charge from infinity to point A, that is W1, upon suppose charge Q, unit charge Q. So this is the potential at point A. Similarly, if I want to define the potential at point B, what we can write, W2 upon Q, charge Q. Now if I want to find, so we know what is potential. Potential we came to know is a condition. Now what is the potential at point? Potential at a particular point is nothing but work done to bring that charge to that point divided by the charge itself. So that is the potential at that point. Now we are going to talk about potential difference. So what is potential difference? We know that potential at this point we know as this one, potential at B we know as this one. So if I want to find, there must be some difference between these two. If I want to find the difference between the potential at point A and point B, we'll get what is called as potential difference. So potential difference between A and B is nothing but potential at point B minus potential at point B minus potential at point A. So that is going to be W2 by Q minus W1 by Q. That is nothing but W2 minus W1 by Q. So this potential difference between A and B is nothing but the difference between work done between A and B divided by the total charge Q. So this is nothing but called as potential difference. Now we know that as we have done some work, suppose in terms of gravitational field, we know we are having a gravitational field like this, and we know that as we carried a ball from ground to some point A, some point A, what we did, we have actually done some work on this ball. And this work is nothing but stored in terms of potential energy of the ball. Similarly, here also we tried to bring a charge from infinity to a point A, and in that case we have to do some external work on that charge to bring it to point A, and that work is stored in terms of energy of that charge, in terms of energy. So that is nothing but called as electric potential energy of that charge. So whenever we move a charge from infinity or any place to any place inside electric field, we have to do some work on that charge, and that work is stored in terms of electric potential energy inside that charges. I hope so you know the basic conditions, basic things what will decide. So you should, by now you should at least know that if there will be no potential difference, there won't be any flow of electrons from one end to another. So in order to have a flow, if we want that electrons should flow from one end of a wire to another end of a wire, we must create a potential difference. Potential difference is very much required. If both the ends of a wire, suppose both the ends of a wire, we have a wire, suppose both the ends, we have a resistor, suppose both the ends of a wire are at the same potential. If both the ends A and B of a wire have same potential, means potential of A is equal to potential of B, then there won't be any flow of current at all. So in order to have a flow of current or the flow of electrons through this circuit, what we need that there must be a difference in potential at the two ends. If there is no difference, it is as similar as a horizontal table and a ball is kept. So since there is no difference of potential, the ball won't move in any direction. If we want the ball to move, we have to either have a potential, either this has to be at a higher potential and this at a lower, or we can have this at a higher or this at a lower. So either of the condition, either we have to have this condition or this condition, then only the ball will move. If we have this condition, the ball won't move. In this case, we say there is no potential difference because both are at same potential. In this we have a potential difference, in this also we have a potential difference. For our convenience, we may give a positive sign to this. We have a positive potential difference here, we have a negative potential difference. That is it. So I hope by now you should understand that what is the main reason behind electrons to move and how electrons move, what is potential difference, and what is electrical potential energy. Thank you.